Could black holes be the key to quantum theory of gravity? A deeper theory of how space and time works. Black holes are interesting because we have a place called the event horizon, where we think that we have a full control of the physics. We understand what's happening, but there's a fundamental clash between our two basic theories of nature, both quantum theory and general relativity together. And the quest to unify those two great pillars of 20th and 21st century physics into what's often referred to as a quantum theory of gravity is in some sense the holy grail to theoretical physicists. So black holes are forcing us into a deeper understanding of what space and times are. And in that sense, I think it's fair to say that black holes are the keys to understanding the universe. I'm Fariz Dzikry from Class 12 Science 5, and we will together unveiling the secrets of black hole in cosmos. The idea of black holes goes back a long way actually. Back into the 1780s and 1790s, there were two physicists, mathematicians, natural philosophers, whatever you want to call them, working at a time that had the same idea, apparently independently of each other. One was a clergyman called Mitchell, and the other was the great French mathematician Laplace. And they were both thinking in terms of an idea called escape velocity. The escape velocity is the speed you have to travel to completely escape the gravitational pull of something, a planet or a star. So for the Earth, for example, the escape velocity from the surface of the Earth is around 8 miles a second. If you go bigger, you make a bigger, more massive thing. Let's go to a star, for example, like the sun. It's somewhere in the region of 400 miles a second. The escape velocity increased because the gravitational pull at the surface increased. What Mitchell and Laplace thought, and I think it's a very beautiful idea, is they imagine in their mind's eye, well, can you go bigger? Can you imagine more and more massive stars, giant stars, such that the gravitational pull is so large at the surface that the escape velocity exceeds the speed of light? And then, you won't be able to see them, because the light cannot escape them. To understand why black holes cause so many conceptual problems, it might be worth just describing very briefly what a black hole looks like. So a black hole, what do you see from the outside? Well, there is an event horizon surrounding the black hole. In some sense, it defines the boundary between the external universe and the interior of the black hole. And if you go across the boundary of the interior of the sphere, then even if you can travel at the speed of light, 300,000 kilometers per second, you can escape the gravitational pull of the black hole. But another description of the event horizon which confused people all the way through the history of black hole research actually was the idea that the event horizon when viewed from the outside is a place in space where time stops. And that's a direct prediction of Einstein's theory of relativity. From the external perspective, there is a central problem through which is still not solved, which is what lies at the center of a black hole. Space and time themselves emerge from what? From quantum entanglement, or some kind of smaller parts or pieces. We don't know what those things are, we don't know the nature of them, but it does seem that there is a deeper underlying theory from which space and time emerge. That is what we call the quantum theory of gravity. And my view is that if we're gonna talk about the origin of the universe, even ask questions such as did the universe have a beginning in time, which we don't know the answer to, then it surely seems to me that we have to understand what space and time are before we can ask and have a chance of answering such questions. And black holes, it turns out, are the object that we can see, that we can observe, that actually exist in nature, that force us down that road to ask questions, sharp, well-defined questions actually, about the nature of space and time themselves. Einstein said that if you look at the nature really carefully and keep pulling at the intellectual threads and keep going and just keep delving down into what nature seems to be trying to tell us, then if you're lucky and persistent, you can catch a glimpse of something deeply hidden. It's beautiful though, isn't it? A glimpse of something deeply hidden, which is the deep underlying structure of nature, the deep underlying structure of reality itself. And I think it's very beautiful. No one really knows. I think it's fair to say where this is going without hints of something deeply hidden.